In this video, we will have a review about the velocity and acceleration when we have rolls without a slip condition. Consider this wheel, assuming that we have a velocity, angular velocity omega, and angular acceleration alpha in clockwise direction. As we are moving to the right direction, we have rolls without a slip conditions. The contact point, point A, has always zero velocity. So we call this point as the IC point, and if you want to find the velocity of any points on the wheel, like point B, point C, or even the center of the wheel, point O, you can use the IC methods to find the velocity. So IC methods. You just need to connect point A to each of these points. Then we are assuming that the whole wheel is rotating about the IC points, so the velocities for each point is normal to the position vectors. This is the direction for velocity of point B. This is the direction for velocity of point O, and this one is the velocity of point C. How we can find the magnitude of these velocities? VB is equal to this length, which is RB/IC, times the omega. The same discussions for point C. VC/IC times omega, and the center of the wheel is, this one was RC/IC, and the last one is RO/IC omega. Look at the RO/IC. This is equal to the radius of the wheel, so it is equal to R omega. So we can find the velocity of any points on the wheel using this analysis. But how can we find the acceleration of, for example, point B, or acceleration of point C? Please remember that for this part, you always need to use the vector analysis. This point, point A, it has zero velocity, but the acceleration of this point is not equal to 0. So in order to solve the acceleration part of a problem, you always need to do the vector analysis. So first of all, before we go through that process, let's see what is the acceleration of point O. Point O is moving on the straight line during the motion. So as the wheel starts from the initial position and goes to the final position during this rolling motion, point O is always traveling on the straight line. So it has a rectilinear motion. We know velocity of O is equal to R omega. So in rectilinear motion, acceleration is always equal to dv over dt. So acceleration is equal to dr omega dt. R is constant, so acceleration of point O is equal to rd omega over dt, or r alpha. So we have the acceleration of point O, r alpha. In this motion, in rolls without a slip, we just know the acceleration of one point. When we start solving the problem, we know acceleration of point O, which is equal to r alpha. So I can use the relative acceleration equation in vector form to find the acceleration of any point on the wheel. For example, for point B, this equation is like this. AB is equal to AO plus alpha cross RB slash O minus omega square RB slash O. Alpha and RB slash O's are vectors. Let me show the RB slash O on this wheel. This is RB slash O. When you wanted to plug RB slash O in this equation, you always need to resolve this vector along the x and y direction. So this is the x component and this one is the y components. In your problems, you always have like an information about this theta angle here, so it's easy for you to find the RB slash O in I and j direction. The next thing that you need to do is to go through this process and find the acceleration of P of B in vector form.